All right, this will be it. And this is the last section. It's inverse trig integrals. I think this is a lot easier section because you're just working backwards. You've already memorized the formulas, or at least I hope you have. And so you just need to look for the formulas, and you have to say to yourself, does that look more like arcsine, arctan, or arcsecant? And we go from there. All right, let's dive into this. Example number 1. I'm going to put the 7 out front, and the dx looks a little weird in the numerator. I'm just going to set it off to the side. That is the same thing. And that just happens to be 7 arcsine of x plus c. Number 2. Again, normally I wouldn't be in this section 5-7. I'd be trying to integrate this maybe in a different chapter, so my mind wouldn't be on these formulas. Obviously, since we are in this section, I'm thinking it looks more like arctan than it does the others because it doesn't have the square root. But normally you wouldn't be thinking of arctan, let's be honest. And so if you try to u sub, you would make the u most likely 1 plus 25x to the 4th, but then your du would have, x to the 3rds in it. You don't have x to the 3rds, you only have x's, and so a normal u sub would fail. And then as a last resort, you would probably think, what about those inverse trig integral trig derivative formulas that we learned in chapter 5? And that's where we want to go. No, you have to take the mindset of being real, almost like a king or queen or some sort of dictator or ruler, and you have to stomp your feet and demand that the problem behaves the way you want it to. You're like, I need this thing to look like this. This is my kingdom. This is what it needs to be. And people are like, all right, you're kind of crazy, but we'll make it that way. So you go out into the field, and you find this serf who's working on the land, and you're like, 25x to the 4th. Your new name is u squared. And they're like, yes, your highness, your majesty, please, don't kill me. And you're like, no, it's fine. That's just your new name. Go forth. And so u squared, let me write a note in the royal diaries here. U squared is the new name for 25x to the 4th. I hereby decree. Decree is something you say if you're royal, I think. Okay. Well, if u squared is 25x to the 4th, then u would be 5x squared. And we're going to finish this off like a regular u sub. It'll just have 3 steps instead of 2. So if u is 5x squared, what's du? And of course, the answer is 10x dx. Way to make me proud to remember the dx. All right, so I need a 10x dx. I have a 15x dx up top. I'm going to kick the 15 out, put the 15 out here, like it never existed. I will give myself a 10, and to make up for it, I'll divide by 10. And this 10x dx becomes a du. So basically, I forced my will on this problem. I made this problem look the way I needed it to look by doing this. Obviously, 15/10 can be reduced to 3/2 in front there. And now it's simply 3/2 arctan of u plus c. But before you circle that, remember that you don't want to leave the u in the problem. U happens to be 5x squared, so that has to go in there. And then you're good to go. Number 3. First off, I have to decide what I want to make this into. Is it closest to arcsine, arctangent, or arcsecant? And hopefully you're ruling out arctan because there's a square root. I think it looks most like arcsine. And so what I need to do is force it to look exactly like arcsine, the memorized formula that I know and love. This is what it needs to look like. And I'm going to command my forces to make sure that it happens. All right, got to wield some power here, yeah. All right, 4x squared, I'm sorry, man, but you got a new name now. Your new name is u squared. Let me write that on the official parchment paper of the kingdom. U squared's new name is 4x squared. All right. Hitherto, forth, henceforth, whatever. So, okay, so u becomes 2x. Just square root both sides. And du, naturally, is going to be 2 dx. I need a 2 dx. I have a 6 dx. I'm just going to shortcut here. I'm going to multiply the inside by 1/3, the outside by 3. I won't make a reciprocal mistake, I promise. So that's going to become 2 dx, which is this du. So this is taking shape. There's just a 1 on top, which matches this 1. The denominator matches, and there's a 3 in front. We did it. So the answer is going to be 3 arc sine of u plus c. And as always, don't write u, write what u is, which in this case is 2x. I haven't done this yet in the first 3 examples, but remember, you can check every single integral problem by taking a derivative. I think I'm going to do that here. It'll also be a good way to review section 5-6. What's the derivative of this? Well, the 3 comes down. The derivative of arc sine is just 1 over square root of 1 minus u squared. 2x times 2x is 4x squared. Oop, times a chain rule. Does the 2x have a derivative? Sure does. Times another 2. Is that what we started with? And absolutely it is. You can see the 6. Yeah, that's great. So super easy to check. Okay, here's number 4. A couple weird things. The dx is in the numerator. I don't really like that, so I'm going to slide the dx off to the right-hand side eventually. I also see that there's an x over x squared. I'm like, well, why did I do that? Why don't I just make it 1 over x? But then I thought, well, maybe it's to my advantage to leave it that way. I'll leave it that way for now. I can always cancel later if I need to, so I got that in my back pocket if I need it. All right, what does this look the most like? And here, to me, it's looking most like inverse secant or arc secant. I can tell because the x squared is first. Unfortunately, it's an x to the 4th. I'll have to figure out how to deal with that. And then the minus 1's at the end. It's definitely not arctan because it's got the square root. Also has the x squared in front, which is sort of like that. It has an absolute value of u in front of the formula. I'm going to try to turn this into arc secant. So I summon all the knights of the kingdom, and I'm like, get out there and make this problem look like this. And so it was done. It'd be kind of cool to be able to rule the world, at least for a day or two. I'd probably get sick of it. I'd be like, yeah. Just want to go back and be a math teacher again. All right, let's see if I can make the black look like the red. I'll start up here. And notice the pattern. We always start with u squareds, and then there's the u, and there's the du. That three-step process, that 3-step u sub never really changes. All right, u squared needs to be x to the 4th. So x to the 4th is getting a new name. It's u squared now. Well, that means that u would be x squared, just square root them both, and du would be 2x dx. And 2x dx is easy enough to find. I'll just put a 2 on here and a 1/2 out front. And 1/2 will drop down. All right, let's compare notes. The 2x dx becomes the du. That looks good. It says so right here in the manual. There's nothing left up top except for a 1, so that's good. This is now the square root of u squared minus 1. That looks good. Oh, check it out. X squared is u. Oh my gosh, that's perfect. Now people are like, well, what about the absolute value? Should I worry? I'm like, no, you don't have to worry because x squared is guaranteed to be positive, so we're good. We've got this. We're ready for an answer, and the answer is 1/2 arc secant of u plus c. You didn't think I was going to forget that, did you? No way. All right, on to number 5. Let's go. Just to change it up a little bit, I've decided to make this a definite integral. So we're going to integrate from rad 2 over 2 up to 1. And we have this lovely integrand, which to me is looking most like, I'm going to say arc sine. It's got the radical 1 minus look. That's arc sine. Hopefully this is getting easier. I think this is an easier section than the previous one. I feel like we've got a rhythm going now here. Well, this has to be u squared. So u squared becomes x to the 4th. Feels like I just did this. Probably because I did. X squared. There's only so many permutations of these you can make. Du needs to be 2x dx. Right now it's 4x dx. I'll just cut it in half. I'll put a 2 out front to make up for it. All right, so the 2x dx that we have right here, that's 2x dx, becomes du. There's nothing left in the numerator, so that's a 1. The denominator is still 1 minus and a square root, but the x to the 4th has a new name. It's now u squared. And I've made this look exactly the way I wanted to. That, my friends, is the integral that is the formula for arc sine of u. But again, you notice I did not put the limits of integration here, here, or here, or here, because the 1 and the rad 2 over 2 are x limits, not u's. So I have to change the u in green back to an x, or in this case, an x squared. So I have to do that first. All right, now it's safe to place the limits of integration on. Now we have x's with x's instead of mixture. All right, and now it's down to the golden sheet. Again, this would be a non-calculator problem. I have not used my calculator yet on this section, as you've noticed, so you know what part of the test this is going to be on. All right, the 2's in front. In goes the 1. It gets squared, which is still a 1. It's an inverse sign, so sine of what is 1? And hopefully you're thinking pi over 2, 90 degrees. We'll stick with radians in calc. Okay, minus. The rad 2 over 2 goes in and gets squared. If you need to write it twice, there's no shame. Go ahead and write it out twice. If you multiply it by itself, it'll become a regular 2 over 4. That'll be 1/2. So sine of what is a half? And hopefully you're thinking of 30 degrees, which is pi over 6. So our answer is going to be, you know what, I'll go ahead and do distributive first. I think that'll be easier than getting common denominators. That's going to be pi minus 2 pi over 6, which is pi over 3. Okay, so we have a full pi minus 1/3 of a pi. That leaves me with 2/3 of a pi, or 2 pi over 3. And that is the perfect exact answer. No calculator required for me. It's looking good. All right, another definite integral. This time I can see a problem here. There is a 4 here. It really needs to be a 1, and it's not. It's a 4. So before I can even start my u subs, I have to deal with it. And so I'm going to rewrite the problem first. I've got to have this 1 here. It just has to be there. I can't overlook the fact that it's not a 1. Now I can go ahead and progress. By the way, this rad 4 is just a 2. Let me just simplify that. You see how the rad 4 made it work because I factored out a 4. All right, cool. I guess I could even cancel the 20 and the 2 and make it a 10. I'll wait on that, but I can do that anytime I feel like it. All right, let's change things around. To me, this looks like arc sine again. So I want it to look like this. So clearly, the x to the 4th over 4 must become the u squared. U will become x squared over 2, which is 1/2 x squared, meaning that du would just be x dx. So yes, I am going to take this 20 over 2, which is a 10. I'm going to kick it out front. So the 10 will be out there. The x dx become this du, so that works. There's nothing left in the numerator, so we have the 1. Everything else matches. We're good. So this is going to be 10 arc sine of u. All right, at this point, the radical 2 gets to go in first. Let's see what happens to it. It's going to get squared, so become a regular 2. But then we divide by 2, so it's a 1. So we have 10 inverse sine of 1. Sine of what is 1? Well, again, that's pi over 2. Minus, put the 0 in, square it, divide by 2. It's still a 0. Sine of what is 0? Well, sine of 0 is 0. Again, some people are like, well, isn't sine of pi equal to 0? I'm like, yeah, it is. Well, what if I put a pi right here? Isn't that a different answer? Yeah, it is. Would it be wrong? Yes, it would be. Well, how do I know whether to put 0 or pi in? That's a good question. Use a 0. All right, 10 times pi over 2 will just be 5 pi, and that is the correct answer. See, I got 5 pi earlier up here, except the font changed when I came to school, so now it's 5p, but let's put an I on the end to make it 5 pi. Woo. No, that's a serious question. Back to this again. How come it's 0, not pi? Remember, arc sine has to stay between 90 and negative 90, or pi over 2 and negative pi over 2. 0's in between them. Pi is not. So don't forget what I taught you in section 5.6. It's still in play.